Okay, YouTube, this video is a follow-up to our last video in which we looked at the identity matrix as being this square matrix of order n, where really this square matrix means just n rows, n columns, but we have ones down the main diagonal and we would have zeros elsewhere, and so we'd have all these zeros up here, down here, everywhere. But essentially this matrix is unique in that if we were to take any matrix A times the matrix I here, we get A, and I times A of course is equal to A as well. So this identity matrix is going to help us define really a new concept, and we're going to say that it is the concept of a multiplicative inverse of a matrix. And so let's go ahead and start with this. Looking at real numbers as a similar concept here, we would say that, let's say we have a real number A. What is the number that we can multiply by that would undo A? And it is the case that anything really times its reciprocal here, something like this, we would get 1. Or if we were to take, let me get rid of the equal sign here, 1 over A. If we were to multiply 1 over A by its multiplicative inverse, which is its reciprocal, we would get 1 here. And so in a real number sense, what we're trying to do is take A under an operation like multiplication with what we call its inverse element. So we'd say the inverse of A in each case. And what we end up with is 1, which, to be clear about this, we get the identity as a result of multiplying by the inverse, multiplying by the inverse. And so this will be a good way for us to check to see if two things are inverses. We're going to see that they undo each other under the operation of multiplication. So we are going to, in this video, we're going to define what we call the multiplicative inverse of a square matrix, and we're going to refer to this inverse of a square matrix as just A inverse. So let's read through this here. We say the definition of the multiplicative inverse of a square matrix. We say letting A be an n by n matrix. If there exists an n by n matrix A inverse, then these statements would hold true. And that is to say that if we took A times its inverse, A inverse would undo A, and what we get left with is what we refer to as the identity element. The identity, that thing that anything times it would give us the same matrix back. And so one thing to point out here is that A times A inverse, because matrix multiplication order sometimes matters, we see that A inverse times A is also the identity element here, the identity matrix. So we say that A inverse, we read this as A inverse, okay, is the multiplicative of inverse of A if and only if when they multiply out they actually give us the identity element. So again, we've seen that matrix multiplication is not commutative. You can't do this in every order, but we say to show that B is some matrix that is the inverse of A, what we'll do is we'll take A times B and B times A, and if both times we get the identity element, the identity, matrix, then we know that they have to be inverses of one another. So taking a look at just this example right here, it says, please and thank you, would you show that B is the multiplicative inverse of A, or that when I take A times B, I get the identity element. And so we will say that A times B equals I if and only if B is the inverse of A. So let's go ahead and do this. Let's go ahead and multiply A times B. And so that's exactly what we're going to do. We're just going to put in A and our B here. We're going to do matrix multiplication as we know how to do. So negative 1, 3, 2, negative 5 is our A matrix here. Say A. Our B matrix here is 5, 3, 2, 1. 5, 3, 2, 1. And because we have a 2 by 2 multiplying by a 2 by 2, we can do this. It is defined because our inner dimensions match, and what we get is a 2 by 2 response. So 2 by 2, we're going to go ahead and fill out our 2-row, 2-column empty product matrix here, and let's go ahead and multiply these out. So in the first possible case, we get first row, first column, we get negative 1 times 5 plus 3 times 2. So negative 1 times 5 is negative 5 plus 3 times 2 is 6. So now let's go first row, second column. So we say negative 1 times 3, which is negative 3, plus 3 times 1. We'd say that's 3 there. Now moving down to our second row, first column, we get 2 times 5, which is 10, plus now move down. Negative 5 times a positive 2 is a negative 10, so we get a negative 10 here. And then our second row, third column, these times these, we get 2 times 5 here is 6, plus negative 5 times a positive 1 is a negative 5. So when we add these up, the interesting thing is we get up here, we get a 1, here we get a 0, here we get a 0, we get a 1 here also. So this is our identity matrix of order 2 in this particular case. And so this is going to suggest that these are indeed inverses of one another. But what I want to do is really be sure. So what we're going to do is we're going to actually switch this around, and we're going to take b times a just to make sure that we still get the identity matrix. And so just to make this quick here, I'm going to go ahead and throw the values in. 5, 3, 2, 1. We get a negative 1, 3, 2, negative 5. And of course, we'll get a 2 by 2 answer here. So I'm going to fill in my blank 2 by 2. But let's go ahead and take a look at the entries that we get here. I suppose that if we do first row, first column here, we would get 5 times negative 1, which is a negative 5, plus now move over 3, move down, times 2 is 6. Okay, now doing our first row, second column here, we would say 5 times 3 is 15, plus, now move over, move down, 3 times negative 5 is our negative 15. So that's going to give us a 0 there. Go second row, first column, we'd say 2 times negative 1 is negative 2, plus now move over, move down, 1 times 2, which is 2. And then over here we'd say second row, second column, we could say 2 times 3 is 6, plus 1 times negative 5 is negative 5. So you can see that in both possible instances here, we end up with our identity matrices. So we can conclude this, we could say that A and B are inverses of one another. And this is how we will verify if two things are inverses, is if they multiply out to be our identity element, then they have to be inverses of one another. Cheers.